So hello friends, Shivansh this side, and today we are going to do a very interesting video on a very interesting in-depth definite integral, which is this one. So of course, even today I'm not telling you answer of that what will it give. Then you will see the answer and you would leave the video. So please watch video till end. Actually, average video duration is seriously very low. Like videos of 15 minutes, only 30 seconds. So let's start. And I can bet this would be the most beautiful integral you would have seen in your life, because this thing gives a very interesting thing which you are going to see now. So let's start it. So to carry out or to work upon this, I have 2-3 ways. Like let me even forget what I am going to tell you. Let me think that how would I start thinking first. I have 2-3 ways of thinking it, like what I know. So one way is what I try upon substitution, because I don't think anything good here. So what I'm doing, e to the power x, I'm putting it as t. Cool. And if you can see, then limits will become e to the power minus infinity 0, e to the power 1. So very interesting integral 0 to 1, and e to the power x becomes t, and dx e to the power x becomes dt. So dx becomes dx becomes e to the power minus x, or dt. What is happening? I am putting e to the power x as t, e to the power x dx is dt. So dx is dt by t. So what I am getting is ln 1 minus t by t, and I hope it's correct. I don't know why I'm doubting myself. It doesn't seems to be correct. I don't know why. Okay, I'm putting it as t, ex dx is dt, dx is dt by e to the power x, e to the power dt by t. Okay, it seems good. Why? So we get one more dreadful integral kind of thing, which is not looking very good. So again, to solve this integral, to see this integral, what can we do? Again, try to think some substitution. I don't think so. So what I am doing, I am applying series of ln of 1 minus x, and series of ln of 1 plus x is x minus x square by 2, x minus x square by 2. Series is basically Taylor expansion or Maclaurin series. Okay, like here it's not Maclaurin series, it's Taylor series only. At the center 1, at the origin is 1. So this is of ln of 1 plus x. So basically what I am doing, putting x as minus x. Okay, let me just for fun confirm this. Is this thing inside the domain? Yes, because ln at 1 is 0, and it's defined if inside argument is positive, and putting values from 0 to 1, it's of course positive, except at 1, which is sad thing. Anyways, even I would like to, just for my interest and just for if you are a good viewer or nice audience, I would like to curve this graph as well. However, I could have curved it, could have made it, but I would like to just see it on Desmos because it seems to be something good. Oh, ln of 1 minus x by x. Wow, it's a nice curve, and we are finding it from 0 to 1. 0 to 1. So okay, it's good answer. Like, from good answer, I mean it's not divergent kind of integral. However, it's not even expected to be divergent. Like, okay, we can't say it's convergent or divergent actually, but it seems to be. Anyways, don't you think it's a very beautiful curve? Always negative. Haha. So what I'm putting here, minus x, and I will get ln of 1 minus x as minus x square by 2 minus x cube by 3 minus x 4 by 4 is what? is ln of 1 minus x, and like my integral demands, I am dividing it by x. Dividing it by x means minus 1 minus x by 2 minus x square by 3 minus x cube by 4 is what? Is ln of 1 minus x by x. I know voice of my mouse would be irritating you, but sorry, what can I do? So integrating it from 0 to 1 each term individually. Actually, in other two ways also I am trying almost the same, like I am doing almost the same thing. So anyways, minus over there 1 plus and integrating each term, you are going to see a magic. And before seeing a magic, please like this video, please subscribe my channel. I really need motivation to show you more of this magic. 1 plus 1 by 2 square plus 1 by 3 square, because basically integral of x to the power n is 1 by n. Like if you are knowing integral, if you're understanding what the hell is happening here, so you must be knowing that. So anyways, and a negative sign ahead. I've put the limits because at 1 every x would be 1, at 0 all would be 0. So this is the thing, and putting negative over there. And what we know with the grace of Mr. Euler, that this is pi square by 6, famous Bessel problem. Minus pi square by 6 is the answer. Isn't it interesting? It is very much. So I have got its answer, and like we have got its answer, and please don't run away after seeing it. You have to watch video till end. You have to promise me that you are watching it till end. Minus pi square by 6. Isn't it very much interesting? Anyways, I have 1, 2, 3 more ways. Now I am going to upload the video. Like this is promoting my future video. In this video, this video is being published on 21st June, and or I think 20th June. And after this video, you are like just after this video, I'm also publishing one more video in which I am going to prove a very interesting result, that zeta at s. And if you don't know what zeta function is, let me tell you. It's basically 1 plus 1 by 2 to the power s plus 1 by 3 to the power s all the way till infinity. Zeta at s. So very interesting result is 1 by is zeta s is 1 by gamma at s, and integral from 0 to infinity x power s minus 1 by e power x minus 1. I am going to prove it in next video. So okay, that next video would be published within 15 minutes of that. So if you are very much keen to see how it's derived, you can watch that video just after this one. So anyways, basically we know, like now we know the answer using method, and I hope I should erase the method one. No, is recording even on? Yes, it's on. It's been 8 minutes, and OBS recorders are really very good app. So anyways, so what I know from the answer, that my answer is minus zeta at 2. You must agree to me that it's minus zeta at 2. Okay, so minus zeta at 2 is minus 1 by gamma at 2. Gamma at 2 is also a function, and gamma function means n minus 1 factorial, and factorial means 1, 2, ... till that number, till n minus 1. So gamma at 2 is 1 factorial, and 1 factorial is 1 itself. So what I mean over here is that gamma s 2 is 1. So integral 0 to infinity x s is 2 by e to the power x minus 1. So if somehow I reduced, is minus cancelled? Sorry. So if somehow I reduce this integral to this thing, then my work is over, because gamma 2 is fully this big thing. Okay, so what I have to do, what my objective is, to have to bring this integral to this integral, and I'm going to do a magic. And if you haven't liked this video till now, first of all you have to like it before I show you a magic. So what magic I'm going to do is that basically 1 dot a is usually written as a itself. So this ln 1 minus e to the power x is actually I hope you have liked the video, or else I'm not going to show it. 1 into ln 1 minus e to the power x, and now I'm going to apply it by parts, integration by parts. And what does integration by parts mean? Like, example, if I have f into g, then this is a very nice formula, and I can even derive it if I get more than 20 likes on this video. However, its derivation is not a very much thing. I don't think you people have to like this video just for that stupid derivation. Anyways, this is a formula. Basically, in f into g, you can take any one function f, and you have to do something like this, like indefinite integral of g minus whole integral of derivative of f into indefinite integral of g as well. So here, for me here, g is equals to 1. G at x is 1, and my f at x, I hope you're understanding where I'm writing and what the hell I'm doing, because I want you to understand. It's very good thing. Okay, and one more time, just for fun, let me see what its domain is. Like, even it's satisfying its domain. Yes, it is. Minus infinity gives 0, which is shit. And like, it's not always negative, it's negative for a while. And again, let's see its curve. Ln of 1 minus e to the power x. Wow. Well, nothing much exciting over here, but anyways, why not see? So using the same formula and doing by parts, integration by parts, we are getting x. Like, okay, of course, we are like, I'm trying that I would put limits afterwards. X ln 1 minus e to the power x minus integral of x into derivative of this thing, ln 1 minus e to the power x. And to take derivative of it, I have to apply chain rule. So from chain rule, first of all, I have to take derivative of ln x, and derivative of ln x is 1 by x, and then derivative of inside function, which is minus e to the power x. So what my derivative is, x e to the power x by 1 minus e to the power x, and a negative sign, and negative gets positive. Now you would argue that you haven't got the same form, which, okay, let me first of all even put the limit, which was, I guess, minus infinity to 0, and putting minus infinity, this gets 0, putting 0, this gets 0, so this term gets cancelled. Okay, one more thing is, even x, basically putting 0 over here gives me 0, of course, but we have to even check it, like, might be they both are giving the same numbers, get cancels to 0. I hope you what I'm trying to understand. I am putting limits over here. Okay, putting limits over this thing is basically nothing but minus infinity to 0. Okay, plus putting limits into this thing. So let's entertain it in our own style. X ln 1 minus e to the power x. What I have to put limits is 0 minus infinity. Sorry, minus infinity to 0. Minus infinity to 0. So putting minus infinity over here, limit x tending to minus infinity. So basically we have to solve two limits. Limit x tending to minus infinity, ln of 1 minus e to the power x into x. So what I am doing, I am putting x as 1 by x. So limit x tending to 0 minus, of course you must be understanding why I am putting 0 minus, because 1 by minus infinity is something 0 but little bit less than 0. Okay, like, of course, while tending, if definitely, however, foolish talks. Anyways, ln of 1 minus e to the power of 1 by h. Let me put, like, show that x is now become h. I hope you understand. If not understanding, please comment, because I'm really getting very less comments on my videos. So sometimes I'm concerned that even I am you try to make you understand what I'm trying to say. So anyways, this is a limit I've got, and now I'm thinking of applying LH. Okay, one more thing I am thinking is that e to the power, like ln 1 plus x is approximately x, that too from series. That is precisely using series only, so it's the one or more or less same thing. Basically what I am doing, e to the power 1 by s h tending 0 minus also tends to 0, so I am multiplying this term here and here, and this term, I mean to say this term tends to 1, and if I can even prove it very easily. What I'm trying to say, ln 1 minus e to the power 1 by h by e to the power 1 by h as h tending to 0 negative. So basically 1 by h tends to h tends to 0 negative, so e to the power 1 by h tends to 0. So if I replace e to the power 1 by h by another number t, ln 1 minus t by t as t tends to 0, and this limit is 0 by applying series. 0, not minus 1, not 0, even minus 1. So I think I'm saying wrong, this is minus 1. So this whole limit become minus 1. Now I am left up with limit h tending to 0 minus negative e to the power 1 by h by h. And it's a very interesting thing, because here you can't apply a very big brain on it precisely. Let me show you why. Because how would you evaluate this limit h tending to 0 minus, of course, that you would say that why not use LH? This gets like derivative of h is okay, it's finished, and its derivative is by h square. Oh, what? Here we are getting squared, and now say no problem, take LH once more, you will get one more square and it would become 2h, so you would get 2h cube. Now you would say okay, take one more derivative, you will get the powers here are increasing, and I hope if you can feel this all tends to 0. Why? Because basically e to the power h is a very strong polynomial. It has infinitely many terms. I don't think this makes sense speaking like this, but basically e to the power x is more fast diverging towards 0 than h, and I can show you this using calculator. What I'm trying to show, that e to the power 1 by h goes near 0 more faster than h. So let's say our h is, I'm telling you of n tending to infinity means same thing. Let's say for h tending to 0, I mean to say that e to the power 1 by h goes more near to 0 than h. So basically this limit gets 0, and in the similar way you would get, if your limit tending to 0, you would get same limit. And basically what I'm trying to say, that this I was really very much deflected from my mission. So basically the parent integral reduces to this one. Which one? Basically integral minus infinity to 0 ln 1 minus e to the power x is equals to minus infinity to 0 x e to the power x 1 minus e to the power x. And obviously to make this thing in the form, to make it in this form, which form? This form. Let me cut it. To make it in this form, I have to put, basically what I'm saying, I have to get this. I have to get sorry. I have to get this integral basically. Anyways, I have to get this integral. Yes, I have to get this integral equivalent to this integral. So what can I do? I have to do nothing. Put x minus x over here. So x over here gets minus x as well as minus minus cancel. It's become infinity to 0. And x e to the power minus x by 1 minus e to the power minus x. E to the power minus x is 1 by e to the power x. E to the power x over here, this gets cancelled and we get its negative of the same thing. Okay, I hope you are able to see, because basically what we are getting over here is that the integral we are seeing is infinity to 0 x by e to the power x minus 1, and we have proved that what we want is negative of this thing. So negative of this thing, basically both are pi square by 6 negative, minus pi square by 6. So this was the second method, and it's a good method, of course. It's a very cute method. And now up to the third method, which is a very direct and straightforward method, which is the method which a layman would like. So what I'm doing nothing. I just applying series over this thing. Like, my opinion is not much modified kind of thing. So I'm just putting series on this. I get what? I get e to the minus out e to the power x plus e to the power 2x by 2. Basically series was minus x square by 2 minus x square by 3 minus x cube by 3 minus x square by 4 e to the power 3x by 3. And now what I'm doing, I'm just integrating it from minus infinity to 0. It will again become e to the power x. It will become e to the power 2x by 2 square. Wow. This will become e to the power 3x by 3 square. Wow. And it goes on. And now putting limits 0, this all will become 1, which is zeta at s, and 1 negative is outside. Putting minus infinity, all will become 0, 1 negative outside, and we get again minus pi square by 6. Okay, that's a great thing. And bonus. And to see this bonus, you have to like the video. If you haven't liked the video, I don't give you right to see this thing. The thing we are doing it for zeta at 2, we can do it for zeta at 3 as well. Basically for that, here we have integrated it one time and then I've put the limits. So what if I am not integrating it, I'm just taking an indefinite integral and then I'm integrating it in next time, then I will get zeta at 3. Basically what I'm trying to say, you have to feel it, and you can even tell me in comments that it's a nice thing. Anyways, basically because here negative, of course, because it's giving minus zeta at 2, so minus zeta at 3 minus integral of ln 1 minus e to the power x. It's getting me zeta at 3, and it can be simply generalized. So for generalizing it, so basically we can write integral as like weights it in d square by dx square for second derivative. So it's often said it's negative derivative, like d minus 1 by dx minus 1. Using this notation, minus integral minus infinity to 0 d by dx minus n minus for 2 0, so basically n minus 2. That is for zeta at n, you have to put n minus 2 over here, because that means if for zeta at 2 you have to do nothing. For zeta at 3 you have to put one indefinite integral over here. So using this notation, I'm saying it's a very cute formula for zeta at n, a generalized one, and it's good to operate it on differentials. Like basically, let me write it neatly: negative of integral minus infinity to 0 d minus n minus 2 by dx to the power minus n minus 2 ln of 1 minus e to the power x. I don't know. Yeah, I should write dx or that is zeta at n, and you can easily see it in the analogous way you have seen it for zeta at 2 and zeta at 3. And let me repeat the notation of negative derivative kind of thing. That means second derivative. Okay, let's start it from pretty basics, so that we can make sense of the notation. So this is first derivative d by dx, okay, and second derivative is d square by dx square. Third derivative is dq by dx cube. So what is zeroth derivative? Basically, what derivative is doing it is take like nth derivative is taking derivative of function n times. So zeroth derivative is taking derivative of function nil times. Basically, putting 0 over it doesn't make any change. So this means simply function itself of fx is fx for all function. So this is positive derivative. So to define antiderivative, let me put minus 1. This is precisely indefinite integral. One time. Putting minus 2, it's antiderivative 2 times. So this is a small idea. I don't know it's a very standard notation or what, because I've seen it 2-3 like at 2-3 places, and even I've seen a weird thumbnail, of course not fully video, that they have even defined it for fractional as well. So anyways, it was, I think, one of the best video I have ever published on this channel. So what our result is that this powerful, this strong integral, let me decorate it, because I really like that integral. I really like this integral. Integral minus infinity 0 ln 1 minus e to the power x is negative of pi square by 6. And also in this video I have assumed that you know that zeta 2 is minus pi square by 6, and if you want that I have to show it, like if you want me to show it or prove it, please comment down. I can make a video on that. And anyways, let me decorate more, because this was the thing for which you and I have wasted 30 minutes of our lives. Like, not waste, it was an interesting adventurous kind of thing. So thanks for watching this video, fan. If you are listening to my statement till here, I'm very thankful. I've got a lovely audience like you, because I don't think that people would listen it anyways. So thanks for watching the video. I hope you liked it, and please subscribe my channel Shivansh Gupta. Please share it to your friends. Please like this video. Thanks for watching. Bye bye.